Now, if you want to learn more about less is an external command that lives on your system. We need to talk about man pages, okay? Man is short for manual. These are the manuals. Commands, most of the commands you're going to deal with will come with a man page. I've been seeing some newer commands not ship with man pages. Hey, come on, guys, make man pages for your program. But we can use man. So man will give us the documentation. So we can say man ls, and this will give you the documentation for ls. Now, the reason I taught you less is because this opened in some sort of pager, and in this case, it opened in less. So you already know how to use less. You know how to use up and down to move up and down and Q to quit. Now you know how to look at man pages. So if we man ls, we can see, hey, here are all the options to ls. There's a ton of options to ls. I don't expect anyone to memorize all these. But if we go down, we can see there's all sorts of stuff here. If I search, I could search for -a, and look, there's the -a argument. Include directory entries whose name begin with a dot. Hey, we used that earlier in this lesson, or previous lesson. So that's how you would find the options in the man page. The cool thing is less, of course, comes with a man page. So less will tell you it's a program similar to more, but it has many more features. Commands are based on both more and VI, so we have like J and K to move up and down. And there are other letters, and it's all described here in the manual. So I won't go over all the options here. I just want to empower you all watching to be able to go look through the man pages. Go find information about the commands you're using. If you get confused, go look up the man page. Go start reading some documentation. I want you to leave this course knowing Bash, of course, but I want you to basically feel empowered to know how to find out more information. So manual pages are a huge source of knowledge here. And of course, the funny one, man. You can get man page on the man page command, which makes perfect sense. Sounds confusing, but it makes perfect sense when you think about it. So even man takes different arguments and stuff. We're not going to learn too much about it right now, but just know that it will open up in your pager. So as long as you know how to use less or whatever pager you're using, you'll feel comfortable with it. All right, so let's dive into man pages a little bit here. Man will show you more than just commands. Man is great for showing commands. If I man mv, remember the command to move or rename a file, we can see mv, move files. In its first form, the utility renames the file by the source operand to the destination path, blah, 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 blah. You can get all the information you want on the mv command here. That's great. But man also shows a little bit more than that, and I will show you what I mean. If I man, you can see that there are sections. The first section of man is for commands. The second section is for system calls. This would be more kernel level stuff. This is how you actually communicate with your kernel. If you're just learning about computers now, this is probably a little bit scary. You don't have to learn too much about this. 3 is like library function calls, so you can find a lot of C standard library stuff in here. And then as these sections go up, they're a little bit different. I think they change operating system to operating system, but in my experience, sections 1, 2, and 3 are almost universal across the different operating systems. But the beautiful thing here is that knowing that, we can also say man1 CP. We don't have to do this, but we could do this because 1 is the section. You can even see the section it's in right here. So the CP command is 1, meaning it's a command. But there's more than that. It mentioned, what were the 2 sections? System call and library functions. So certain things are not commands. They are just library functions. So if I were to man, I won't go too far into this, but let's man printf as an example. As you can see, there is a printf command. But I didn't want that. I want to know the C standard library printf. So I'll have to run man3 printf. And there we go. Now I have a different man page, and this shows me the C code if I wanted to include standard IO and actually run the printf function. So this is just how you know like what section you're in. If you omit the section, man will go through and try to find it on its own. So it'll check section 1 first. If it's not there, it'll check section 2. If it's not there, it'll check section 3, etc. If you explicitly give it a section number, then it will go look for that specifically. So something to keep in mind, something to be aware of. This is going to be useful down the road. So these commands exist on our system, right? Like CP is an external program, MV is an external program. What do I mean when I say external? Well, let me show you something. Let's go ahead and run a different command. We have history, right? Remember I ran this command and there's the history of commands we've written. So let's go ahead and get the man page for history, right? If I run man history, we get this. This is weird. Built-in one, shell built-in commands. See the built-in command description in the appropriate shell manual page. That's interesting. So what is it telling me? It's telling me that history is not an external command. History is built into Bash. So instead of using man, I should use the Bash way of getting documentation. And this is key because a lot of people don't know about this. A lot of people will trip themselves up on this. Help is what you want. Help is the man equivalent for Bash built-ins. So if we run help and then we run history, we can see, there we go. It doesn't go into a pager by default. I have to scroll it with my mouse, but you can see that it gives me all the options that the history command takes, because history is built into my shell, not an external command. So how can we tell this? You may be familiar with the which command. So I can say which ls, and it will tell you where on my system ls exists. So I can just run ls and my shell will find it. I could also run bin ls and it will run largely the same thing. That's all well and good. But if I were to run, let's say, which history, there's nothing, doesn't print anything. That's because history is not an external command, it's built into the shell. Another command, please take this command to heart. It is super useful if you're in bash. Type. The type command. If I run type history, we can see that history is a shell built in. Hey, beautiful. That's awesome. Where has this command been my whole life? Type ls. ls is alias to that. Oh, it looks like I set up an alias without even telling you guys. That's a little bit confusing. Is ls built in or is it a program though? Type -a ls. -a will tell you every type from top to bottom. And what that means is bash will execute it in order from top to bottom. So it'll tell you exactly where it found it on the system, but it will also tell you what it has. So bash will run this alias first. This is super useful because there are commands out there that are both. That might be a little bit confusing, but let's echo hello. Okay, what's the man page for echo? Well, here's a nice man page for echo. Look, echo takes a -n argument. It only takes -n. It doesn't take anything else. But if I run echo, I can give it -e, and it seemed to work just fine. Why is that? Because echo is built into my shell, but echo is also bin echo. This confuses people. This trips people up. Really, I mean this. Think about this. Learn the type command, because people would be like, oh, I don't really know how to use echo. I'm using an example here, but echo is one that trips people up. I don't really know how to use it. Let me pull up the man page. Oh, it doesn't seem to have the options they're talking about. That's interesting. Yeah, because the man page is for bin echo, and that's not what you want. You are executing the one that is built into your shell. When it's built into bash, you need to use help echo. And here are the things that echo supports in bash. We have a -n, we have a -e, we have a -E. We have all these sorts of fun little characters when we're giving it a -e. Echo in bash is more feature complete than the echo that's on my system. So just keep that in mind. If you take nothing else from this, please just take away type. Type is so useful. People use the which command, which only finds the external command. Type is useful for telling me everything about it. Remember we set up an alias for rm? If we run it, we can see that rm is aliased and rm is bin rm. So the type command, super useful, amazing. Please commit that to memory. Of course, just like we can run man, we can run help. And we can get all the information on how to use the help command. So yeah, I don't know. That's kind of fun. Help-m, display usage in pseudo man page format. I didn't even know this existed. What do you think that does? Oh, wow, it makes it look like a man page. That's really cute. So if we take this and pipe that into less, hey, it looks like a man page. Wow, I genuinely didn't know this. That's actually really cool. That is super useful. See how knowing how to use these tools and compose them together with pipelines is super useful? You can make the computer do a lot of really cool things. So you might be wondering, okay, Dave, you showed me that echo is built in. You showed me that history is built in. What else is built in? Well, don't worry. We're going to use another built-in command that I'm going to teach you about right now. It's for completion, but we're going to use compgen. This is built into bash. You're not going to have to use it much unless you're writing completions by hand. But compgen -b, this will list all of the built-ins. Super useful. I'll clear the screen and we'll run it. Here is a list of all the things that are built into bash. So you could go through each one of these and learn about them if you want to. They might also be external commands, like kill is built into bash, but kill will also exist on your system. So be mindful of that. The kill on bash might work slightly differently than the kill that's on your system. So, but yeah, compgen -b. The nice thing is, just like all the other commands, we could pipe that to grep for anything that has a K in it. And there are the built-ins that have K in it. I don't know why you'd want this, but you could. You could pipe this to less and you could page through them. So yeah, pipeline, super useful. Any program that just outputs text or data, we can run it through a pipeline. Super useful. Also, like we learned this before, I just want to cement some of these concepts. We could write this out to a file. We could make built-ins.txt. We ran that. Nothing happened. It didn't print anything. That's good. That's the Unix philosophy. Nothing happened there, so we can assume it was successful. Cat built-ins.txt. There we go. There's our list of built-ins stored in that file. Why you'd want to do that, I have no idea. I'm just showing you that data can be translated and written to files. It could be written to pipelines. You can do all sorts of fun stuff. History is the same way. So you could do history pipe grep to less. And there we go. There's every time we ran less here. There's some weird examples from when I was like working on a previous video, so ignore some of this weird stuff here. This is my actual history file on my machine. But yeah, as you can see, just because like they're pipelines, we can still pipe grep, we can pipe that to less, we can do all sorts of fun stuff. So yeah, neat.